Hello guys, so my name is Baghdadi, right? Baghdad, you guys can call me Baghdad because I'm here to provide for all your mathematical needs. So yes, so let's start from here. In this video we're going to talk about concepts of increasing and decreasing functions, as well as concavity and convexity and points of inflection, as well as minima and maxima, but I'll just introduce the concepts in this video. So let's start with, so to talk about these ideas, let's first have a graph. This is our x and this is our origin, right? Let this be just random digits here. So this can be, this can be, so we're going to have a random graph, just a random graph. Then let this point be point 1, then let this point be point 2, let this point be point 3, then let this point be point 4. Alright, so a graph is always changing, values. So if we're going to talk about a specific graph, a specific point on a graph, then it means we're going to talk about where this graph has a tangent. So in this case we're going to be talking about point 1. Okay, so let's talk about an increasing function. All right, so what is an increasing function? A function is increasing if, when we are increasing the x values, the y values are also increasing. So that means at that point a function is increasing. So now, for example, at point 1, from point 1, okay, let's say we have 0.8 here and 1.1 here. So if we move from 0.8 to 1.1, you realize that the values of y will have changed, and they will have increased, right? So at point 2, we can see that as we move towards the greater values of x, the function is going up. So it's simply increasing. Alright guys, so that's what an increasing function is. And in terms of its derivative, a function is increasing, and if it's increasing, its derivative at that specific point should be greater than 0, meaning an increasing function at a specific point has got a positive derivative at that point, right? So let's quickly talk about a decreasing function. Alright, so we can redraw that. Okay, so let's talk about a decreasing function. So now a decreasing function, if a function is decreasing, it means at that point that we're considering, when we increase the values of x, the values of y are decreasing, right? For example, at point 3, a decreasing function, yeah. So for example, at point 3, let's say we have 2.9 here and we have 3.1 here. So if we move from 2.9 to 3.1, we realize that as x increases, y is decreasing from, for example, let's say this is 3.5 to, let's say this is 2.5. So if x increases from 2.9 to 3.1, y is reducing from 3.5 to 2.5. So that means the function is decreasing at 3, right? Okay, so this is what an increasing function is, guys. This is what a decreasing function is. So now let's talk about concavity. So okay, we'll talk about concavity. We're going to draw again. We're going to draw just another graph, right? Just another graph. So this is 0, then we can have 1, then 2, then 3, then 4, then just 1, 2, and 3. Just a random graph, right? just a random graph. Oh, by the way, if a function is decreasing, it means its derivative at that point is less than 0, right? It means its derivative at that point is less than 0. So yeah, I forgot to mention that, sorry. So okay, so we'll be let's talk about a function that is, before we go to concavity, let's talk about this point. So let's talk about this point and this point, right? So now this point, at this point, so we said from this point the function was increasing, and from this point the function was decreasing, right? So now at this point the function is neither decreasing nor increasing. Even at this point the function is neither decreasing nor decreasing. It's neither increasing nor decreasing, and this is a stationary point. We call these points stationary, as well as this is also a stationary point, right? So we have an increasing function, a decreasing function, and a function that's neither decreasing nor decreasing, so that function is stationary. All right, so from here now we can go to the concepts of concavity and convexity, as well as points of inflection. All right, so let's have something like this. These are okay. So this point, let's first deal with this point. So we have concavity, okay, let's say concave and convex and point of inflection, right? We have 3, this is 2, this is 1. So this is a tangent, guys. This is a tangent. This is also a tangent to the curve, and this is also a tangent, right? Okay, so a function is a function. Let's call this point. So this is at 4, and then this is at 3 roughly, and then this will be our 2, and this will be our 1. So this function, the function at this point is concave downwards, right? It's concave downwards. Why is it concave downwards? It's concave downwards because we have 2 points, this point and this point, both lying above the tangent. So if this point and that point, if 2 portions on both sides of a point, let's say 4, are both lying above a tangent, then the function is concave downwards at that point, which is 4 in this case. So here we have concavity, here we have concavity, all right. So now we have a point like this one. This is convex. This is convex upwards, right? This is convex upwards because 2 points, this portion and this portion, are on both sides of this point, which is in this case 2, are both lying below the tangent, which is this. So at this point we have a convex. This is convex upwards. All right, so because both this point and this point are both lying downwards, are both lying below the tangent, and then we have a point like this one. Remember, this point and this point are both lying below the tangent. Even here, this point and this point are both lying above the tangent, but here we don't have such a case. So we have 2 points on the curve that are lying on different sides of the tangent, which is this point is called the point of inflection. Okay, so now in terms of the derivatives, with concavity and convexity and points of inflection, here we deal with the second derivative, right, which is d squared y and dx squared. So for example, at point 2, since the point is convex, this is also called a maximum point, so which is a convex also. It's going to have a negative second derivative. So yeah, it's going to have a negative second derivative. So a convex has a negative second derivative, and a concave will have a positive second derivative, and this is also called a minimum. And indeed, it's minimum. It's the minimum point on this curve, and here this is the maximum point on this curve. All right, so now the point of inflection. So the point of inflection is this one now in this case, which is on point 3. So here the second derivative is equal to 0, and when the second derivative is equal to 0, it's really hard to tell whether a function is maximum or minimum. So in this case, what you do is you have to check. Okay, you have to check, and this checking, we are going to see the checking in the examples that are going to follow. So as I said, this is the maximum and this is the minimum, and also concave here, then here it's convex, right? This is the point of inflection. Okay, so in this video we can end here. Catch me in the next video for some examples.